Today we're doing lesson 7.14, reasoning about angles, part 1. 14.1 says draw a clock. Kieran is drawing a clock. He draws a pair of perpendicular lines to find the placement of the numbers 3, 6, 9, and 12 around the circle. How many degrees is each angle he has drawn so far? Jackson? 90. All of the angles he's drawn so far are 90 degrees. And you know that because when we make perpendicular line segments, or perpendicular lines, they're all 90 degrees. And I've got to find what I did with my stylus. I must have carried it around. So what you need to write down is $90 degrees. Perpendicular line segment, or perpendicular lines / line segments make right angles. Okay, it says help Kieran find the exact placement of the numbers 1 and 2 on the clock. The first question says, how many new lines does he need to draw to add the 1 and 2 on the clock? How many new lines does he need to draw, Athena? 2. And what angles should be formed between the 2 lines he has already drawn and the new ones? Okay, so this is what he's already drawn. He drew perpendicular lines, and he put a 12 up here, and a 3 here, and a 6 here, and a 9 here. If we're going to draw a 1 and a 2, how many sections will this be split into, Avis? 3. So how many degrees would that be? Go ahead. 30. Because if you split 90, you divide 90 into 3 angles, 9 divided by 3 is 3, and then the 0 comes over. So each one will be 30 degrees. So what you can do, well, here, let's fill this out first. What angles should be formed between the 2 lines of 30 degree or 30 degree angles? And then it wants us to draw the lines precisely and place the numbers 1 and 2 on the drawing up at the top. So if we go back up here, the way that you're going to do this is to take your protractor and put the middle of the protractor in where the 2 lines meet and line it up with this line, and then find the 30 and put a dot, and the 60 and put a dot, and then connect the dots. So I'm going to do that as well. And I know it's a little bit tough because of how small this is. So, and then your center dot is what you're connecting to. So, there's 1. And then we're going to write a 1 and a 2. And then we're actually going to do that all the way around the clock. So, I'm going to Theta 60. Oh, that one was terrible. Let me try it over here. Oh my goodness, I lost it. There we go. All right, 4 and 5. You guys doing this too?
Yeah.
Okay. I think I'm gonna eyeball it because I'm having a really hard time doing that with.
Eyeball it.
Seven and 8. Three, 10 and 11. It's not perfect, but that'll work. Okay. Next page. What angles are formed by the hour and minute hands of the clock at these times? So, the first time is 6 o'clock. So, what is the degree of this angle? Autrey?
180.
Yes. So, on 6 o'clock, you're going to write 180 degrees. And that would be like this, a 12 and a 6. Okay, what about at 8 o'clock? What degrees would it be? Avis?
120.
That, let's see here. So this was, so at 6 o'clock it was 180.
It's 140.
No, that's not 140. Do you remember what each of these, how big they are? How many degrees?
5.
5 minutes. But how many degrees? You just wrote it on the top of the last
30.
page. 30 degrees. So watch. 30, 60, 90, 120. So that is a 120 degree angle. But it can also be 150, 180, 210, 240. Does that make sense? So it is a 100 because the distance between them is 30, 60, 90, 120. But if you're counting from where it started at both at the 12, that would be 240. So it's both. Okay? So the 8 o'clock,
So do I get myself?
yes, would be a 120 degree and a 240 degree angle. What is 120 plus 240? Colton? 360. Does that make sense? Because the clock's a circle. Okay. So 9 o'clock. So 9 o'clock is going to look like this. That's of course what kind of
90 degree angle.
just a minute. Okay. That is what measure of angle, Fisher?
90 degrees.
90 degrees. Now, if we also count and see how from 12 to 9 by 30, what else would it be? Avis?
270.
Yes. So 90 and 270 is what we're going to write. And that's because, let's look at, let's count by 30s till we get to 9. 30, 60, 90, 120, 150, 180, 210, 240, 270. Okay, so that's 270 here and then 90 here. Does that make sense? To cover the whole clock. Then we have 11 o'clock. So at 11 o'clock, how big is that angle, Fisher?
30 degrees.
Say that again.
30 degrees.
30. Okay. So it is 30. And then if we look at how far it would the hour has traveled from the 12, it's traveled how far, Autry?
320.
No, Ari?
330.
330. We got to get to 360. So 30 and 330. All right. And then at 12 o'clock,
It's lunch.
it's a full
hour. 0 is 360.
Fazil, 360 degrees. Okay. So, when the clock starts at 2 o'clock, okay, so it starts at 2 o'clock. Cameron, stop doing that. Starts at 2 o'clock and it travels to 2:05. How many degrees has the minute hand turned? Athena? So it started at 2 o'clock and traveled to 2:05.
5 minutes.
How many degrees is that? Go back to your previous page. How many degrees? 30. Does that make sense? Okay. 30 degrees. Hey, what about when it goes from 2:05 to 2:30? So now it's at 2:05. If it goes down to 2:30, how many degrees has it traveled? 30, 60, 90, 120, 150. So here we're going to write down 150 degrees. This is kind of, okay, 150 degrees. Explain how we know. Each 5 minutes is equal to 30 degrees. 2:05 to 2:30 is 25 minutes. And then we can write this. So we're going to set it up like an equivalent fraction. 5 minutes is equivalent to 30 degrees. So if we have 25 minutes, it's like, what do you multiply 5 times to get 25? Jackson? And if you do it to the top,
You do it to the bottom.
so what we're multiplying by is 5. So if we're multiplying 30 by 5, It's the basic fact, 3 times 5, which is 15, and then we add on a
0.
so 150 degrees. So this is why we learned how to do equivalent fractions before we did a lot of other things, because like converting measurements, degrees, all of that stuff can be turned into equivalent fractions. The minute hand on the clock is vertical at 7 p.m. Sometime later, it makes an angle that is 120 degrees from where it was at 7 p.m. What time could that be? Okay, so at 7 p.m., it looks like this, right? 7 p.m. If it makes a 120 degree angle, then that means it travels 30, 60, 90, 120. So that's one way. So what time is that?
4:30.
7:20. The red hand is the hour hand. So it's pointing between the 7 and the 8. So that's going to be 7:20. Or this is where it started. We can go back 30, 60, 90, 120. So then that time would be
7:40. 6:40.
6:40, right? So 7:20 or 6:40. $6.40 or $7.20. How many degrees does the minute hand turn in 10 minutes? This is our starting place on this one. We know from our previous problems that 5 minutes is 30 degrees. 5 minutes makes a 30-degree angle, right? So, how many degrees would a 10-minute change be? Avis? 60. What do you multiply 5 times to get 10? 2. And if you do it to the top,
You do it to the bottom.
what's 30 times 2? 60. Does that make sense? Okay. So a 10-minute change would be 60 degrees. What about a 1 minute? Well, if we know that 10 minutes is 60 degrees, then 1 minute would be how many degrees? What do you do to 10 to get 1? What do you divide 10 by to get 1? Zerelda?
10.
10. And if you do it to the top,
You do it
to the bottom. So what is 10 divided by 10? 1. And 60 divided by 10? 6. So look, guys, remember when we were doing decimals, how I showed you like 1/10 is the same as 10 hundredths and all that? Well, this is similar. We had 10 on top and 60 on bottom. We're just taking off the 0. So 10 minutes is 60 degrees, or 1 minute is 6 degrees. So 1 minute is a 6-degree angle on the clock. 4 minutes, we just use our other comparisons to help us. So we know now that 1 minute is 6 degrees. And 4 minutes then would be, don't shout it out, raise your hand. Todd? Todd, what do you multiply 1 times to get 4? 4, and if you do it to the top, so Todd, what is this times that? Got a multiplication table right there. Yep, 24 degrees. Does that make sense? Okay. 4 minutes would be 24 degrees. Okay, so we're gonna stop there on that one.